Okay, so now are coming the two most difficult talks. They're going to be very short, but I would like you to encourage the two next speakers. They are PhD students. It's the first year we do this exercise in US. We ask them to present in 180 seconds what has been the scope of their study. And the idea is to promote innovation and also acknowledge how the creativity of young researchers will become the source of inspiration for the next applications, the next maybe traditions in the future. So because it's extremely difficult to summarize several years of study in 280 seconds, I would like to ask you to encourage the next two speakers with a round of applause because it's very hard. So, and thank you for being courageous.
Is my microphone on? Oh, yeah. Okay, when should I start? You need to tell me. Okay, so actually I'm now a postdoc at the Viticulture and Enology department at UC Davis, and I spent the last 5 years on how grapevines respond to drought stress, with focusing on the water uptake of grapevine rootstocks and on the water transport properties of the grape pedicel, which actually connects the fruit to the parent plant. And to do this research, I used microtomography. And so we used tomography to look at the structure and the function of plant tissues by bringing our plants to the advanced light source in Berkeley and image those plants there. And what we could do by using this novel technology is that we could actually analyze plant tissues in 4D. So we could look at plant tissues, how it changes in space, and how the tissue changes over time under periods of drought. So for me, having this opportunity to use this new technology really opened up new pathways for me in terms of what I did in my research and what I will do in the future. So some outcomes of this research was that so we identified two grapevine rootstocks which differ in drought resistance in a way that the rootstock Vitis riparia is able to repair their water transport system by removing gas embolisms out of the xylem vessels that usually occur under drought stress, which was very unique, whereas the other rootstock, it's Vitis champinii, did not have this ability. And the other discovery we made is that the pedicel of the grape actually changes in hydraulic properties after veraison. And we found that in the water transport system in the grape pedicel, there are blockages forming, which can have a huge impact for fruit size, sugar accumulation, or irrigation management in the future. But, well, I suppose more research is needed and my time is over. So thank you for listening.
So, thank you very much, Thorsten. Of course, we have time for a few questions.
Oh, great.
If there are any questions.
Probably don't remember any of what I said.
Did you say riparia was the one that repaired the...
Yes, yeah, that's not a coincidence. But it's good to remember, Vitis riparia can repair the xylem embolisms, yes.
So I have a question regarding repair after embolism. Do you have any insight regarding how within Vitis vinifera different varietals have a greater or lower ability to recover post-embolism or cavitation?
Yeah, that's a good question. So what we think now is that so grapevine species that usually are native to relatively wet habitats, they usually have a better ability to repair the embolism. And Vitis ripariae is one of those species. Whereas when you have species which are more native to arid habitats, like the southwestern US and Texas or so, where you usually find Vitis champinii, so there we don't find this ability to repair embolism. So currently we're also starting to look not at just the embolism formation, which can disrupt the water transport system, but also on structural changes in the root tissue, which usually happen before the embolism starts. So we're trying to find out what's the coordination of these events to really kind of map what's happening during drought, sort of thing.
I have another question. Where do you think your work will lead you? Like, what kind of applications do you foresee in 5-10 years down the road?
Yeah, so I think one application would be to make it more predictable, or to identify grapevine rootstocks that are more drought resistant in a more physiological sense. I also think that our research can have a big impact on developing new irrigation strategies when we actually understand in more detail the fundamental processes that happen in the grapevine plant. Because often I think the world is not so easy as we always think it is, and everything is very complex. And the more research you do, the more complex things are getting, which makes things more and more complicated. But so there might be solutions in the future, hopefully, but maybe.
Thank you. It's great work. Yeah. Thank you, Thorsten. So the second speaker is now Aun. Okay, so I'll let you look at Virginie.
Sure.
Good luck.
Hi, I'm Jake Uretsky. I'm a PhD student with Andy Walker at UC Davis. I'm just going to talk a little bit today about my research in breeding drought-resistant rootstocks. So the first step in breeding drought resistance is actually defining it, because it can mean many things, right? So on one hand, we think about it from the grower's perspective. So it means like maintenance of yield, or maintenance of berry quality, or maybe improvement of berry quality. And then on the plant's perspective, it's maintenance of vine and vineyard health over the long term. And all that has to happen with less water. Okay? So there's one approach to kind of breeding for drought resistance is in trying to select for specific responses to water stress. But that's really not a great approach for breeding, because really all aspects of plant growth are affected by water stress, and probably almost all the genes are affected by water stress. So probably a better approach, and the one that I'm taking, is really to look at the more intrinsic properties of the plants, like the growth habit of the plant or the form of the plant, because that in turn influences plant growth, the acquisition of resources, and the allocation of resources in the plant, and then in turn influences the response to environmental changes. Okay? So, and historically in plant breeding, most of the major advances have come about by identifying and exploiting these plant forms that really allow for more efficient and better management practices. Okay? So far though, we've mostly focused on shoot traits, shoot growth habit, because roots are kind of a pain to work with. Okay, but I'm interested in rootstocks, so I'm really interested in the roots, in the form of the roots. So during the past couple of years, I've developed screening techniques for evaluating the root systems of plants, and using commercial rootstocks, I've found consistent forms that kind of coincide with the performance that we see under different environmental conditions. So I'm using populations now to understand the genetic basis of those traits, and I've designed experiments for relating the physiology of the response to drought with these growth forms of the root systems. And the idea in the end is to then use this information to select for advantageous root growth habits or root architecture and combine that with things like salinity tolerance, nematode resistance, vigor, stuff like that, and develop sort of multiple rootstocks that meet a range of grower expectations, keep the plants healthy, and do it for the long term. So that's the goal.
Are there any questions? Are there any
Dorson?
Yes?
So what kind of tools are you going to be using to measure the drought resistance?
So one of the things that's difficult is simulating drought, right? Especially on a short-term scale. So one of the things that we do is we work mainly in pots, and then we dry down the pots. And one of the things I'm really interested in is how well does the root system maintain its ability to uptake water even after it's been dried down? And it seems like some of the architectural traits that we look at are related to that response, and some of these architectures, they actually, once they've been dried down, they retain that ability to uptake water. So that could be a really valuable thing, I think. All good.
Thank you very
Oh,
much.
you're welcome.
Unless you have other questions.